All right, everybody, welcome to RIP version 2, the second version, right? All right. Oh, and for you curious cats here, I put it in the Bellman-Ford algorithm. A lot of people have been asking. Now you know what it's all about. So you can go have at it. All right. Remember, distance vector routing protocol, what does it mean? That it cares about distance and direction. All right. Based on the hop counts, what's the hop counts? 15. 16 is unavailable. It's over. All right. And I'll obviously use the Bellman-Ford algorithm for that. It's a classical routing protocol, so it doesn't send us subnet mask information. That's why we must use the no auto summary. Any distance vector routing protocol, we use no auto summary. Now, here's the abbreviation for it, or this is what the abbreviation stands for: Routing Information Protocol version 2, just if you didn't know. Also, authentication between routers, it includes that as well. It all depends on your iOS feature set, which we'll be talking about later on in the course. And RIP version 2 can also become a default route and point other routers to the outside. But we'll be doing a lab to show you all this stuff. Okay. Unfortunately, RIP does cause routing loops, but fear not. We have mechanisms to avoid that, which are what? Split horizon in the interface. If it's not, it should be on by default, but if not, just go in there and do IP split horizon. And then you have poison reverse, which means what? It sends out to everybody in the network a maximum hop count. Okay, a maximum hop count of 16 that says, hey, you can't get to this network because it's now poisoned. It's 16. You can't get to it. It's maximum hop count. Also, the hold down timers. We have update timers, we have hold down timers, we have flush timers. So the hold down timers actually is the one that says, hey, I want to hold this network for a period of time, and then later on it goes away or it gets updated, and that resets that. And obviously you need to know that multicast address, which is 224.0.0.9. All right, and that every 30 seconds, which can be tweaked, by default, the entire routing table gets updated. All right. Now, obviously, you know that IPv4 uses ARP. So in order, I'm going to summarize this real big or real quick. What that means is if I send out for another individual, that means I say, hey, who are you? I send in an ARP request. I need your MAC address. Well, okay. Well, here's my MAC address. That's an ARP reply. So ARP is working. Not in IPv6. All right. Does RIP converge quickly? No. Why? Because count to infinity. And that's the problem with all distance vector protocols. That has a convergence issue due to the count to infinity problem, which it thinks is going over and over and over again. And this is where these routing loops come from. We'll be doing all sorts of configurations that we've done before, but we'll do again. And this will be the lab that we will be doing. So guess what? I will see you inside. Hello, here we are inside the lab. As you can see, this is the packet tracer. Right now, everything is pretty much configured. And I can show you here on router 0. It has a name. You can see right there, router RIP. Let's do a show stars. You can see from the beginning. All right, boom. Here's fast Ethernet 0, 10115. Okay, we have RIP version 2. You can see 10.0.0.0. I don't use the 10.1.1.4. It's going to summarize it anyway. That's why we use the no auto summary. And then we do a show IP route. And then here we're already using RIP as a default route, pointing to where it needs to point to get where it needs to go. Okay, because in this particular router, and let's put this guy right over here. Let's click this back. All right, we see we do enable show IP route. We say, hey, look at that! It's showing me 10.1.1.4. I'm connected to the 10.1.1.8, and somehow I'm connected to the server, but it doesn't show me anything else. Can I ping anything else? Let's find out. Ping 10.1.1.5. And I can. Why? Because I'm using RIP as a default route. If you look at the configuration, somewhere in here it should say it. Show router RIP. Here's the network that I'm advertising. It doesn't say it there, but you can see that when we go back to router 0, you can see that RIP is advertising, and I'm doing it under this particular router right here. Okay. All right, so let's go ahead and get rid of all this stuff so we can do things from scratch. This is very simple. All we're going to do is get rid of RIP. We're not going to get rid of the IP addresses since you already know how to put IP addresses on routers, I'm assuming. What did I do that for? No need for that. No, yes, you do. Config T, no router RIP. All right, do WR. Let's do it for the second router. Bring it all the way here. Click on the CLI. That's what I did when I went up there. If you didn't see that, enable, config T. I like to abbreviate too much. Conf T, no router RIP. Nah, it's only with one I. Enter, WR, and then go to the last router. And then config T, conf T, no router RIP. So now we have no routing protocols on our routers. Do show IP RIP. What? Oh, do show IP route. Sorry. Can't type today. Okay. All right. So all we know is about our connected neighbors. That is it. All right. The 10.1.1.8 and the 192.168.1.0, which is that server, which already has an IP address. All right. And we do a show IP in brief. Show IP int. Come on now. Show IP int. Oh, sweet mother. In brief. Okay. Here we do a show. Okay, do show IP in brief. There we go. You see the IP addresses. The gateway is 1.254, and then of course 10.1.1.10 for the fast Ethernet 0.1, meaning the server address is going to be 192.168.1.1. All right. So let's go back to router 1. And let's start configuring our routing protocol. So router RIP version, just ver2, and then network 10.0.0.0, nothing new to you guys and gals. All right, and then we just do no auto summary, and you can do that. Remember, it doesn't matter what you put in, I'll prove it to you in the next router. All right, I have done this before in real life routers, in Burl, and any simulator. It's the same thing. This is how disinfected routing protocols work. All right, they will summarize the Cloudflow boundary. So this is the basic configuration of RIP. And there's no real advanced configuration of RIP. All right, so this is RIP. All right, so let's go to router 2 or router 1, whatever the case may be, because we started in 0. We're going to do, now you can see router 1 is connected to 2 different networks. Watch. Router RIP network 10.1.1.4. And then give me an error, did it? Network 10.1.1.8. And then I'm going to still say no auto summary. So this inspector. Do WR. But if you were to look at the start, do show start, you go down, it summarizes it. It summarizes it anyway. This is when it sends out the updates. When it sends out the updates that you see that, hey, this is what's, I'm sending you this subnet mask. This is what the real network is. So don't waste your time typing in the network. Just put 10.0.0.0 for the Cloudflow boundary. All right, less typing. All right, now we go to our last router. And then we do, get a clean screen here. Router RIP version 2. Network here, we have 2. networks. We really do have two networks, 10.0.0.0, and then network 192.168.1.0. That's it. Now summary, WR. All right, so do a Control Z, do a show IP route, and I am not getting anything. Show start. Why is that the case? Let's take a look. Version 2, 10.0.0, 192, normal summary. Okay, that looks good. Oh, I forgot to put version 2 here. I forgot to put version 2 here. Okay. This is so quick, it's not even funny. No router RIP. Router RIP version 2. Net 10.0.0. All right, DWR. Let's just check router 1 to make sure that we do put version 2 on that one. We sure did. All right, well, we're here now. So let's do a show IP route. Show IP route. All right, and let's expand the screen. And you see that you have the 10.1.1.8, the 10.1.1.4, the 192.168.1.0. Let's see if we can ping the server 192.168.1.1. Remember, ARP, and we have full connectivity going all the way across. Lovely. Okay, so no biggie there. All right, so basic configuration of RIP. Nothing that we need to be really concerned about. Just understand how things got there. That's what we're really, I think, what Cisco's looking for us to understand. All right. And it's the routing process. The routing process. Remember, this letter means RIP. You have a table up here that tells you that that is RIP, right? Because there's a little R in front of it, and I don't see it somewhere up here. Here it is. RIP. Okay. This is the network that you're learning about, the administrative distance, and how far away that network is. All right. 10.1.1.6. That's where you're learning it from, the 10.1.1.6, which is that interface. So I am learning about that network that is one hop away through that interface. And I got updated 21 seconds ago. I will be updated 21 seconds. All right, so now what we want to do is we want to tell everybody, because we go to the last router, all right, and we look at its routing table, show IP route. Everything should be hunky-dory now. All right, and it is. All right, we see the R for 10.1.4, and we're connected to two networks. No big deal. But one of the things that we're going to do in this particular router, the last router, config T, is say router RIP version 2. I was kind of anal. I always do that. Now there's a command. It says default information. Default information. And then all you're going to really do is say originate. Originate. All right. And that tells all the other routers, hey, you want to go somewhere? This is the way you're going to go. All right. This is the way it's, you got to get to that server. Do WR. That's it. The routing table looks just the same. Okay. But that is a candidate default, because if you look and say at router 2, if you look at router 2's routing table, show IP route, do show IP route, sorry. Now it's telling you, hey, there's a default route, router RIP, okay, and it's only one hop away via this network. This is pointing you to the outside, all right, default originate. So this is the default route but for RIP, and we still have actually everything is still the same. Okay, the only difference is we got a little extra R there that shows it as the default route. So for any routes needing to go to a certain location, this is the way to go, default route. All right, because we still have connectivity to the pane 192.168.1.1. We still get there without our problem. So that is the default originate command. Nothing out of this world, okay? But just understanding how things get from one place to the other, that is what they're looking for. That is what they're looking for. Here's what we configured, the default originate command, okay? So that way, within the routing protocol, so it sets a default route for it. So everybody gets to go out to the actual server, or it's pointing out this way. If you want to go to the outside, hey guys, this is the way to go. Follow me. This is the default route. That's all. That's all that is. And we're out of the lab. You've done it before. Nothing new. Very simple. Now you see it. No big deal. We did the default route. If you didn't see it before, you saw it now. There it is. Okay? So just go over it over again. I'll see you in the next one.